projects. In this video, we are going to explain about a project titled Car Popularity Prediction in Machine Learning. Our mission is to create a precise and adaptable system that predicts car popularity based on the diverse attributes. By harnessing the potential of the powerful machine learning algorithm such as logistic regression, SVM, KNN, and many more, we aim to offer the car buyers valuable insight into the preferred vehicle's popularity. Our project is dedicated to optimizing the car selection process, enhancing the customer satisfaction, and contributing to the automotive industry competitiveness. The primary goal of this project is to build a highly accurate and robust system that can predict the popularity of cars based on the various attributes. To achieve this, the project leverages a diverse range of machine learning algorithms including logistic regression, SVM, KNN, Neo-Bayes, random forest, voting classifier, AdaBoost, and CatBoost. These algorithms collectively form a comprehensive and versatile predictive model. The system will analyze the crucial car-related data such as price, capacity, maintenance level, and luggage safety, and of many more. By providing the valuable insights into the popularity of the selected cars, the project aims to empower the car buyers with informed decision-making capability. Ultimately, the project seeks to enhance the car selection process, improving the customer satisfaction, and contribute to overall efficiency and competitiveness of the automotive industry. These are the basic requirements that are needed to build this project. The software requirement: Python IDEal with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirements: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. And the first step, the necessary Python libraries are imported to support the various functionalities throughout the project. These libraries include Pandas, NumPy, Matplotlib, Seaborn, sklearn, and Flask. Pandas is used for data handling, NumPy for numerical operation, Matplotlib and Seabird for data visualization, sklearn for machine learning algorithm, and Flask for creating the web interface. And the second one is exploring the dataset. Here, the dataset containing the information about the car such as price, number of person it can accommodate, maintenance level, luggage safety, and other relevant features is explored. This exploration involves examining the data to understand its structure, checking for any missing value, and getting insights into the distribution of each attribute. And the third one is data visualization. Data visualization techniques are applied to present the dataset characteristics visually. This step involves creating the various plots and charts such as scatter plots, histograms, box plots, and heat maps to visualize the relationship between the different features and identify the outliers and understand the distribution of the target variable. Data visualization helps to gain a deeper understanding of the data set and provide the valuable insight into the pattern and trends. And the fourth step is data cleaning. Data cleaning is performed on handling the missing value, removing the duplicates, and addressing any inconsistencies in the data set. Missing values may be filled using the imputation technique, and duplicates, outliers also be removed appropriately or treated. This step ensures the data set is clean and usable format for training the machine learning model. And the fifth one is splitting the data to the training and the testing set. The data set is divided into the two subsets that are training set and the testing set. The training set is used to train the machine learning model, allowing them to learn the pattern and the relationship within the data. The test set is kept separate and used to evaluate the model performance on the unseen data, providing an estimation of how well the model will generalize to new data. And the sixth one is of building the model. In this step, the multiple machine learning algorithms are employed to create the predictive model for the car popularity. The first one is logistic regression. As a fundamental and widely used linear classification algorithm in machine learning, it primarily applied to the binary classification task where the target variable has two classes. Here it's of acceptable or often as are no. However, it can also extend to handle the multi-classification as well. The algorithm calculates the probability of the input data belonging to each class using a logistic function and then assigns the data to the class with the highest probability. It models the relationship between the features and the target variable using a linear equation, which makes it simple and interpretable. And the second one is SVM, stands for Support Vector Mission. Is a powerful and versatile classification algorithm used for binary and multi-classification tasks. It finds the optimal hyperplane that best separates the different classes in the feature space. The hyperplane is chosen such that the margin between the nearest data point of each class is maximized, providing the better generalization to unseen data. SVM can handle the high-dimensional data and is effective even when the data is not linearly separable by transforming the input features into the higher dimensional space using the kernel function. SVM is widely used in various applications and anomaly detection too. And the third one is KNN, that is K-nearest neighbor, is a simple and effective classification algorithm used for both the binary and multi-classification tasks. It assigns a new data point to the class of its k-nearest neighbor in the feature space based on the distance metric, such as Euclidean distance. The value of k determines the number of neighbors considered for the classification. KNN makes the prediction based on the majority class among its k-nearest neighbor. It is a non-parametric algorithm. It does not take any assumptions about the underlying data distribution. And the fourth one is naive Bayes. It's a probabilistic classification algorithm based on Bayes' theorem. With the assumption of feature independence, it is commonly used for the test classification and spam filtering tasks. Naive Bayes calculates the probability of a data point belonging to a certain class based on the joint probability of the features given in that class. Despite its simplifying independence assumption, naive Bayes often performs surprisingly well on various classification tasks, especially when dealing with high-dimensional data. It's computationally efficient and requires a relatively small amount of training data. And the fifth one is random forest. Random forest is an ensemble learning technique that combines the multiple decision tree to improve the prediction accuracy and reduce the overfitting. Each tree in the forest is trained on a random subset of the data and a random subset of the features. The final prediction is made by averaging or weighting the predictions from all the individualities. The random forest can handle both the classification and the regression tasks and is robust against the noise and outliers. And the next one is voting classifier. Voting classifier is an ensemble method that combines the prediction of multiple individual classifier using voting and have the two types, that is of hard voting and the soft voting. In hard voting, the final prediction is the majority vote, and in the soft voting, the final prediction is the class with the highest average probability across all individual classifiers. By combining the predictions of the diverse classifiers, voting classifier can improve the overall prediction accuracy and enhance the robustness of the final model. And the next one is AdaBoost. AdaBoost means of adaptive boosting is an ensemble learning technique that combines the multiple weak classifiers to create a strong classifier. A weak classifier is a model that performs slightly better than the random guessing. AdaBoost assigns higher weight to the misclassified data point in each iteration, allowing the subsequent weak classifiers to focus more on the challenging data points. The final prediction is determined by combining the votes of all the weak classifiers. AdaBoost effectively handles both binary and multi-classification tasks. And the last one is CatBoost. is a gradient boosting library designed to handle the categorical features effectively. Gradient boosting is an ensemble learning technique that combines the multiple weak learners in a boosting manner. CatBoost is specifically optimized to work with dataset containing the categorical features without the need for extensive pre-processing such as one-hot encoding. It automatically handles the categorical variable and improve the performance of the model. CatBoost provides the faster training times and better predictive accuracy, making it a valuable tool in various machine learning projects, especially when dealing with complex and high-dimensional data set. And the seventh one is training the model. The machine learning model are trained using the training set. During the training process, the model learns from the input features and their corresponding target labels to make the accurate prediction. The model adjusts the parameters based on the training data to improve their performance. And the eighth one is the user give input. A user-friendly web interface is created using the Flask, a web framework, and the Python. This interface allows the user to input the data related to a car such as price, capacity, maintenance level, and luggage safety. Users can input their car features through the interface for the prediction. And the ninth one is the given input is pre-processed for prediction. The user's input data is pre-processed in a similar manner as of the training data. This step involves encoding the categorical variables, handling the missing values, and ensuring the data is in appropriate format for the trained model. And the 10th one is trained model is used for prediction. The pre-processed user input is fed into the training machine learning model, where each model makes the prediction with the core popularity based on the provided input data. Each model provides a different prediction, and the outcome will be based on the combined prediction from all the models. And the last one is final outcome is displayed. The prediction from all the models are collected and analyzed. The final outcome, which represents and predicted the car popularity, is displayed to the user through the Flask web interface. The result provides the valuable insights for the car buyers, allowing them to understand the predicted popularity level of the selected car based on the input features. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of different files within it. The first one is the CatBoost training that involves of the CatBoost algorithm within it. And the static folder contains of the different folder within it of CSS, images, forms, JavaScript, Bootstrap files within it. And the template folder contains of the HTML documents within it, and it typically includes the files like home, index, notebook, result, sign-in and sign-up pages. And the app is an py file, likely contains the information related to the front-end logic. It includes the code that is written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file, contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And the sign-up is an DB file that stores the user information. And to execute the project, we developed a Flask framework as a front-end for the user interface. And the total code, output and the graphs are all present in the IPYNB file named as notebook. And for the execution, first we need to copy this code folder address and then open the Anaconda prompt. Here we need to change the disk location as of F because our code folder is present in F disk, and then write the command of cd space and paste this directory code folder address. and because this command is used to change the current directory to the code folder's path. And then here we need to write another command, that is python space app.py. Here this command will execute the Python script and perform a runtime check for any syntax errors or the logical issues. And then click on enter button. By running this app.py file, the Flask framework will host the application locally at the default address. And we need to copy this address and paste it on any web browser as of your choice. And I use the Microsoft Edge and then paste this address. Copy this and paste this and click on enter button. Here we redirected to the home page contains of the title of the project and contains of the two buttons as of sign up and sign in, and click on the sign up button. It redirected to this page containing of various details in it to create an account, but I already am an account, that's why I'm using the sign in button to redirect to the sign in page and then apply the username and password as of admin and then click on login button. Here it redirected to this page and containing of the buying price, maintenance cost, number of doors, number of seats, luggage, boot size, safety rating of this. We need to enter these details as of buying price. It's of up to of 1 to 5. 1 means of the low price, 2 means of middle, 3 means of above, and 4 means of that above, and 5 means of highest price. On that choice, I am entering the 1 as the same way for the maintenance cost too. As of up to 1 to 5 rating, and we need to enter based on that. And the number of doors is of 2, the number of seats is of 4, is of 2, and the luggage boot size number of seats is of 4, and the luggage boot size is of 2, and the safety rating is of 3, and then click on submit button, and the given input gives as of acceptable car. And for another time we click on the back button and re-enter this on your result, and I'm entering as 3, 2, 3, 4. Luggage boot size is of 3 and safety rating is of 3, and then click on submit button. Here the given input is predicted as of acceptable car. In this way we can predict the car popularity by using the various machine. And in conclusion, the study highlights the significance of machine learning technique in predicting the popularity of car. As the technology continues to shape our world, the fields of artificial intelligence, machine learning, knowledge engineering, and deep learning are becoming increasingly crucial. By leveraging these tools, the study successfully addressed the challenge of predicting the car popularity, treating it either as regression or classification problem. The findings demonstrate the potential of machine learning, providing the valuable insight into the dynamic of business and their popularity. This study not only contributes to the advancement of the field, but also paves the way for the future applications of the machine learning in understanding and predicting the various aspects of the industries and the markets.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.